So we've got a quotient rule problem here. So I'm just going to quickly, I'm going to actually do this one. I've written dy dx, but we're going to go in the other one. So our question here is find the gradient of the tangent to this function y equals x squared all over the square root of x squared plus 5 at x equals -2. So realistically, if we have a function y equals u over v, which we do here, we've got u equals x squared and v equals square root x squared plus 5, and we might even change this to x squared plus 5 to the half just because it helps doing an integral. It means our derivative of y with respect to x is going to be u dash, which means the derivative of u times v minus u v dash all over v squared. Now this rule we get this from the product rule, but for the minute let's just roll with the quotient rule. This is the form it's in. So we need the derivative of u, so u dash here will be 2x, and v dash, which we're also going to need, sorry, my u's and v's are not looking different enough, is going to be half x squared plus 5 to the negative half, and then times by 2x. Now, this half and this 2 will cancel, so I'm going to have u dash is 2x, v is, just for the minute, I'm going to write it in bracket notation, x squared plus 5 to the half, minus u here is going to be x squared, and then times by v dash, which is going to be, I'm just going to move this x that's sitting here out the front. It's going to be x times x to x squared plus 5 to the negative a half. And this is all over x squared plus 5 to the half, which is v, and this is squared, so v squared, remember here, so v is this term in the bracket squared. So let's just change here. The half and the squared are going to cancel here, and let's clean this up a little bit for our next step. So we're going to have dy dx equals, we're still going to have 2x and then square root x squared plus 5 minus x cubed. Oh, sorry, this was a minus here. This x cubed. And then because we are times by negative half, we're going to have x squared plus 5. And this is all square rooted here. And this whole thing is over x plus 5. Now, to get a common denominator here, well, it's up to you here. We can simplify, or we can purely we can sub in our next value here. Now we've got our derivative. It doesn't matter that it's like a bit of a messy function. We can sub in our -2. If you wanted to, we could clean this up. And I might do that at the end of this video. I'll just quickly solve it. So we're looking at, so this is dy dx. And so now we're looking at dy dx at x equals -2. So this means dy dx equals 2 bracket, so we're subbing in, that's the 2x, -2, and then we've got square root -2 squared plus 5 minus -2 cubed all over square root -2 squared plus 5, and this is all over -2 squared, sorry I missed a squared there, plus 5. All right, so if we start multiplying out here, we've got -2, so -4, sorry, that's a So we're looking here, 2 times 2 is negative 4. So we'll stay blue, negative 4. Now, inside this square root, we've got negative 2 squared is 4, and then 4 plus 5 is 9. So we're going to have 9 minus, this is 2 cubed, which is 8. But we've got the negative sign there. So remember, 2 times 2 is going to be negative, negative gives us positive, and then we times it by another negative. So because it's got an odd power, it's going to be a negative here. So we're looking at this being negative 8. And this is over the same square root we've worked out previously, which is square root 9. And this is all over 9 because negative 2 squared is 4 plus 5. All right, I'm just going to put dy dx here. All right, now if I clean this up a little bit more, I've got negative 4 times 3, square root of 9 is 3, plus 8 over 3, and this is all over 9. All right, so next step here, let's multiply this out. So I've got, because it's divided by 9, it's the same as multiplying by 1/9. So that times negative 12 plus 8 on 3. All right, so we've got that all done, and so we're going to multiply this out. Yep, so we get here negative 12 on 9 plus 8 on 27. All right, equals negative 4 on 3. Or actually, no, we should just get a common denominator of 27 so we can work this out. So 9 times 3 gives us 27. So we're going to do 12 times 3, which is negative 36 on 27 plus 8 on 27 equals 28 on negative 28 on 27. Negative 28 on 27. All right, and that should be the solution there. I don't actually have my graphics calculator on me at the moment. Otherwise, I would quickly double check that. As I said, graphics calculator, graph, and then trace with your derivative turned on will just give you a quick check. So you might need to calculate what 28, negative 28 divided by 27 gives us negative 28 divided by 27, which I don't know off the top of my head, is approximately negative 1.04. We go to 3 significant figures. That's actually important. I would need to double check that. But I've just done that algebraically without any resources, so I'm going to just pause there. Thanks, guys.